Hi, we'll be solving FRQ 2014 number 1. So, the question is, grass clippings are placed in a bin where they're going to decompose. The amount of grass clippings is modeled by the equation A of t, and it's measured in pounds, t is measured in days. So, the first part A is asking the average rate of change from 0 to 30. And this is really simple. There's the formula, which is A of 30 minus A of 0 all over 30 minus 0. And we plug this in, we get 6.687 times 0.931 to the 30th minus 0.931 to the 0, which is just 1 all over 30. And plugging this into the calculator, we get 6.687 times 0.931 to the 30th minus 1 divided by 30. This gives us minus 0.196 or minus 0.197. Both of these work, and it's asking for units of measure, which is just pounds per day, as we have underlined. Part B, it's asking for A prime of 15. Best way to do this is just to find the formula for A prime of t, and then plug in 15. So we differentiate A of t. A of t equals 6.687 times 0.931 to the t. That means A prime of t equals 6.687 times ln of 0.931 times 0.931 to the t. This is chain rule. It's pretty simple. So using this, we can plug in 15 and we will get minus 0.163. So we get minus 0.163, or if you round it, minus 0.164. Both of these work, and the units is just going to be the same, pounds per day, because it's derivative, so you have to take pounds and then divide it by days. Now, we want to explain this in the context of the problem. Well, that's really simple. It's just using the terminology grass clippings and pounds and days. So basically, the way we can interpret this is that at day 15, the rate of change of grass clippings equals minus 0.163 pounds per day. That's all we have to do. Okay, for part C, we want to find the amount of grass clippings in the bin. Well, we want to find the time t such that the number of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. And this is just plugging in the formula for average value, and this is the equation we want to solve. Now this obviously can be evaluated, and actually let's evaluate it using Wolfram Alpha. Okay, and it gives us 2.75264. So in reality, we want to solve A of t equals 2.75264 75264. And solving this, we get t equals 12.414 and t equals 12.415 days. And both of these work because one's rounded and one's just the first 3 digits. So for part D, it's saying that the linear approximation for A at L equals 30 is a better model. So first, let's figure out what the linear approximation is, because we have to use that to predict the time where there will be 0.5 pounds of grass clippings remaining in the bin. So L of T, well, the formula for linear approximation is just going to be A of 30, because it tells us to use 30, and then plus A prime of 30 times t minus 30. And basically this will give you the slope at equals 30 and A of 30, and then it just creates a line for approximating values close to 30. Now we want L of t to equal to 0.5, because that's what the question is asking. And first we need to know A of 30 and A prime of 30. And using the previous formula, we get that A of 30 is 0.782928, and A prime of 30 is minus 0.055976. So using these facts together, we can solve it using Wolfram Alpha again. And to do this, we will say 0.782928 plus minus 0.055976 times t minus 30 equals 0.5. And this gives us the answer t that we want, which is t equals 35 .0545, or approximately 35.054. Okay, so there are a few tips and tricks for FRQs that can help increase your grade on the AP test. So let's write some of them down. So the first tip is just to actually read the intro text. Now this gives you all the background information, usually gives you units, and gives you a good idea of what the problem is going to be about. And this is very important. A lot of people don't read it and they have no idea what they're doing. So make sure you do actually read it. Now, a second tip, when you're doing the problems, solve the problem. Like, don't make sure you don't solve a different problem. Solve the problem that they are asking. Because, like, if it's asking for average rate of change, then don't find something else, only find average rate of change. That's usually how the FRQs are going to work. You do not need to find anything before finding average rate of change. Some useful resources for problems similar to this one. In our textbook, there's section 3.8, which is exponential growth and decay. In addition, we have section 9.4, which is models for population growth. Finally, we have this website, Calc AB practice, and it gives you past FRQs, past scoring guidelines, which can be very useful, because I think the best way to do well on a test is to do practice tests.